All right, we're here at the bottom of page 4 in section 1.4. And now a chance for you to try based on simplifying each algebraic expression. Now this is one where I went just slightly harder on the try problem. See how you do with it here. Pause the video so you can have some time, and then we'll reveal the answer. Okay, pause it now if you still need more time, because the answer to number 56 is going to be 9x plus 5. Now what if the problem looked like number 60? Okay, just continue. You can see as the numbers grow bigger, they get more and more involved. But the steps are still the same. When we are simplifying, we're trying to remove any parentheses using distribution if that's what's available, multiplication over addition, and then combining any like terms. So in this case we have both potentially, because we definitely have distribution happening, and that's the first thing that needs to happen. So let's go ahead and distribute the 2, and it's 2 times something plus 2 times something. I'm distributing over that 1 plus there, so 2 multiplications, and I get my 5x and my 4 in there, and I still have my minus 3 on the outside. And now I've got multiplication, multiplication, and subtraction. So the 2 multiplications come first. If you need to think about it this way, go ahead and regroup that 5x to 2 and 5 so that eventually you end up with the 10 times x, or 10x. Plus 2 times 4 is 8, and then still the minus 3. And then you look to combine like terms. In this case, 8 and 3 are like terms. You can think of it as 8 plus a negative 3, or just 8 minus 3. Those are exactly the same. 10x plus 5 is your final answer on that one. Let's look at the practice plus here. The reason why I picked this one out to do is because it's a great mental exercise to kind of convince yourself at each step why you can go from one line to the other. But I wanted to do it together for 2 reasons. One, there's a couple lines in there that I don't think are very intuitive, meaning I don't think most of us would come up with it on our own. The second reason why is I wanted to say that this is an example of looking at somebody else's work and then trying to explain why they did what they did. This is not necessarily how I want you to write out problems. I'm not the type of teacher that says you have to do it exactly like I do it. Okay? Now, your work has to be neat and readable, but your steps might look a little different. You might not switch things around. You might do some of these things in your head. You might not undistribute at one of these bottom steps here that I'm going to show you. So, I've said it a couple times already in this set of lessons, but find a method that makes sense to you and it's getting you right answers consistently. That means over and over and over again, you're getting right answers so that you can be confident in what you're doing, okay? And if it's not exactly the same way as I do it, that doesn't matter one iota. You just get strong in the math. And if you aren't sure if your method is correct, you're just getting lucky, then come see me. That's definitely something we should talk about and let me look at, okay? And then I get a chance to learn something new too. Alright, so we're starting with 5 times x plus 4 plus 3x, and then we're seeing all these steps that someone has done, and we get a chance to defend it, why they got to do what they do. So you're actually looking to see what's different between the first and the next line, and the next line, and the next line. So we start with 5, outside the parentheses, x plus 4, plus 3x, and then the next line still has the plus 3x, that didn't change. What's changed is, inside the parentheses is now 5x plus 20. Well, how did we get there? Well, they used the distributive property. Okay. And then from this line to this next line, what's different? Well, again, the plus 3x is the same. The parentheses are still here. It's just that now, instead of 5x plus 20, it's 20 plus 5x. So these got switched around. And what allows us to switch around? Well, the commutative property of addition. Next is all the pieces are in the same spot, the 20's first, then the 5x, and the 3x, but the parentheses has moved. They're now down here at the end. In a sense, things have been regrouped. We're going to deal with two things inside the parentheses, a different two things inside the parentheses first before anything else. This is known as the associative, who I associate with. Associative property. And since they did it with addition involved, associative property of addition. Sorry about my handwriting here. Now let's look to see what happens next. And this is the one where I think I think most of us would look at it and go, what? Why do you get to do that? This is really a demonstration of why we get to combine like terms. Why that's a thing we can do in mathematics. What happened here is the 20 stays the same. Pardon me, a little yawn there. And you started with 5x plus 3x inside the parentheses. The next step shows that x outside the parentheses. It's like an undoing of the distributive property. And I believe when you do these in the book, they'll just list distributive property as the answer for this step. Then what that allows you to do based on order of operations is we can go ahead and combine the 5 plus 3 and get 8 times x, or just 8x. And then finally they switched around for their final version, this nice finished polished look that has the variable term in front, the constant term in back. And the reason they're able to go from 20 plus 8x to 8x plus 20 and still it all be equivalent, that's key here. These are all equivalent. I haven't changed the value of anything. I've just used my knowledge of mathematics and algebra to move things around. And this is the commutative property of addition as well. Okay, and just one more page left in this section. We'll do some translating in page 5.